Hello, my name is John Cowart. I'm an instructor here at Lincoln Tech. I'm here to talk to you a little bit more about the refrigeration cycle today. To go in depth from my other video, we learned in the last video we have four major components: compressor, condenser, metering device, and evaporator. Usually your metering device and your evaporator will be found inside your home or the structure you're trying to cool. Your compressor and your condenser will usually be found outside the structure or outside your house. It could be outside the refrigerator. It just depends on the application we're looking for. Okay, we'll talk a little bit more about this today. We talked about we have a discharge line connecting the compressor to the condenser, a liquid line connecting the condenser to the metering device, the expansion line connecting the metering device to the evaporator, and the suction line from the evaporator to the compressor. We also talked about that the compressor causes a pressure increase, the metering device causes a pressure decrease into the system. That's how we have our high side to this side, our low side to that one. We also find SRT high in our condenser, that's saturated refrigerant temperature high. You use a PT chart to find that. Same thing with your SRT low. You find your PT chart to find the low side pressure. Also, we have four basic sections in here. We have high temp, high pressure vapor. In this part between the compressor and the condenser, we have high temp, high pressure liquid between the condenser and the metering device. We have low temp, low pressure liquid going into the evaporator, and we have low temp, low pressure vapor going back into the compressor. And this cycle goes on and on until the space that we're trying to cool is satisfied. So if you go in your house, it's 85 degrees outside. The house temperature is probably, let's say, 82. When you first come in, you turn on your air conditioner, you set it to 72 degrees. The AC will run, so the cycle will run until it lowers the temperature of that house down to what you have set it, then it will cut it off. After that, as the temperature begins to raise up in the house, the thermostat will sense that and turn back onto the system. And like I said, it will run and run and run. We use air mainly as a medium to go across here to do what we want to do. So basically you have cooler air come in. I'm going to say cooler air. Basically in, that goes across the coil outside. Basically, you have warmer air out. So basically what that means is you've got a cooler air that goes across this coil. Well, to cause a change of state, and that's what happens in the condenser, we go from a vapor to a liquid, what we need to do is a temperature difference. So the coil of the condenser is going to be warmer than the air going across it. So even if it's 100 degrees outside, it may be, the coil itself may be 120 degrees. And that's how we cause that change of state on the condenser. All right, let's go over to this side. So inside your home or inside the space you're trying, you're going to have warmer air going in. Just like that. Well, this evaporator is colder than the air going across it. So the heat is going to be absorbed into the refrigerant because it's cold. It always goes hot to cold. And you're going to have cooler air coming out. So the heat that you feel inside your house gets picked up in the evaporator, goes through the cycle, and gets rejected out here at your condenser. So you can go outside your house today if it's not too wet and check it out. When your AC comes on, you will feel warmer air coming out on top of that. A colder air will come in. Doesn't mean it's cold like cold to the feel, it's just cooler than the condenser. Same thing here. The heat is absorbed, it boils off in the refrigerant, creates a vapor, comes down and goes back around and continues the cycle until the space is cooled down. Now let's talk about a couple of terms that you might have heard. First term we're going to talk about is superheat. Superheat. What is superheat? Well, when you talk about superheat, superheat is always a vapor. And basically what that means is once this liquid has boiled off, any more heat we add to it just raises the temperature and doesn't change the state. So we have superheat, and you pick up superheat all through here, all the way into the compressor. That's why we have that line insulated so we don't pick up excess superheat going through an attic. So superheat is on this side right here. So don't think of it as being hot. That's a misconception. Just think of it as once something's a vapor, any heat we add to it is going to cause the temperature rise without a change of state. Okay, let's come over to this side. Let's talk about another term, de-superheat. De-superheat happens right around here. As soon as you come out that discharge line all the way into your condenser, about the first 3 rungs of the evaporator coil itself, that's where we have de-superheat. So what's basically happening is you've got a really hot, high temp, high pressure vapor coming out here. We want to drop the temperature as much as we can to get that close to where it's going to be able to condense into a liquid over here. So we drop a lot of heat in between. So a condenser does 3 things. It, 1, de-superheats. 2, it causes a change of state. A vapor into a liquid. 3 is another word you may have heard of. It's called subcool. Subcool always refers to a liquid. So when you subcool, you start to subcool here, and you're subcooling all the way up here into the metering device. What that means is we've taken away all the sensible heat we can from a 100% saturated liquid. So subcooling, we want this to be subcooled. Now what does superheat and subcool tell us when we're working on a system? Basically they tell us how the charge is, how much heat we're picking up. Are we getting a solid column of liquid refrigerant all the way up to the metering device? You do have what you call flash gas. What is flash gas? Flash gas. Flash gas up here, basically, that's flask. I'm sorry. Flash gas. So basically, any gas or any vapor that does not get condensed into a liquid here into our condenser goes through the system, has to go all the way back around. If we have too much flash gas coming out, it's because of maybe a dirty condenser possibly a restriction in the line. What happens is we don't get a full column of liquid up here to this metering device, and that causes the system to be inefficient. So flash gas is something we do not want. We're always going to have a little bit of it, but we do not want excess amounts of it. So when we get over here to the metering device, we're going to have a pressure drop. So basically this goes into a large line, and then it goes through a tiny little orifice in there, and that's what causes the pressure drop. As we do that, we will flash some, but we should have at least 80% liquid and 20% vapor as we flash through there. That means we've got at least 80% liquid going into our evaporator, and that is where another change of state takes place. That's where the heat that's being blown across this evaporator is going to cause that to boil and turn into superheated gas as it goes back down the compressor. So basically we're absorbing as much heat as we can. We're going to reject as much heat as we can right over here. Basically the refrigeration cycle does not change regardless if it is a refrigerator. If it is a air conditioning system, it is a large commercial chiller, big industrial ammonia systems. These things will continue to happen. This is what you want to happen. This is how we get things to be from a warm temperature to a cool temperature through this refrigeration cycle. And the flow will always go like this. Later on in later classes, we'll add in other things in here to make the system do different things that we want it to, especially if we want to get real low temperatures. But right now, let's just stick to this part. So in a nutshell, this is your refrigeration cycle. This is what you should remember. High and low side. The compressor and the metering device, part of it's in the high side, part of it's in the low side. The two places that you will find saturated liquid and vapor at the same time are going to be in your evaporator and your condenser. We never want liquid going back to our compressor. The compressor is a vapor pump. You cannot compress liquid. Basically, if you get liquid down in a compressor, you can have it, damage it to the least, destroy it and blow it up to the worst. So these are some of the things. But get this in your head and memorize this refrigeration cycle, because this will be never changing in whatever part of the field you go into. Thank you very much. I hope this has helped you explain. More videos to come. Thank you.